Okay, so here's your 5 a day. I'll keep on putting them up there for the lessons that I've made, but I won't spend time going through them. You can email me if you have any questions about the answers. Here's your title for today. We're looking at congruence and proofs from our new chapter of geometry in the plane and proof. In your book, like normal, I expect you to write down the title of today and our keywords. Okay, so congruent shapes, hopefully you know this already, but congruent shapes are exactly the same size and shape. For example, these two triangles are congruent. If I label the vertices, I will be able to compare the corresponding angles which are equal and the corresponding sides which are equal. And overall, I can say that the triangle ABC is congruent to, note this 3-line symbol here, triangle EDF. The order of the letters does matter. A and E are the angles that correspond to each other, so they go in the same position when I'm listing the vertices in my triangle. These transformations produce congruent shapes, so reflection and rotation and translation. Each of these faces are congruent to each other. So to prove that two triangles are congruent, we must use one of 4 reasons. And we need to give reasons why these sides or angles are equal. Now, some of you will also use AAS. That's just a variation on ASA. So this is what they look like. SSS, S standing for side, 3 sides are the same. Here, the order is really important. So this bit's wrong. Sorry. So this one should be side, angle, side. So you can see from the diagrams, I've got sides indicated here. So we should have side, angle, side. And it's 2 sides and the included angle are the same. And it's important that it's the angle in between the sides, not a different one. ASA, 2 angles and the included sides. So again, the order is important. We can have AAS, though I will accept that, although I won't talk about it too often. And RHS, where R is right angle, H is hypotenuse, S is side. You should be familiar with those 4. I do expect you to write down the orange box though. If you haven't done that yet, then pause the video and do so. So here's 8 triangles. I want you to find the pairs of congruent triangles, state the reason for congruency, and make sure you list the angles of the triangle in the correct order. Pause the video now and have a go at this. Okay then, so this is what you should have. Note that sometimes we have to work out additional pieces of information. So for example, with this one and this one, I need to calculate that 63 and 27, they add up to 90. So therefore I know that this is a right angle. And with this, what have I called it? NOM and XWV, I need to calculate this third angle to check that 4.5 centimeters or 45 millimeters is in between 2 angles that are the same. Okay, have a go at these questions. These are from your textbook now. pause the video while you do that. Make sure you mark your work as you go. Okay, then just a pointer. This side here, BD in question E, AC in C, AC in A, AC and D, and BD here. These are called shared sides, and a shared side, i.e. one that's included in two different triangles, then that's going to be equal because it's the same side. Okay, then I want you to have a look at this. We've got the names of 8 quadrilaterals. No, I haven't. Names of 7 quadrilaterals, diagrams of 7 quadrilaterals, and explanations or descriptions of their properties. I want you to match them up together and pause the video while you do this. Okay then, so what we should have, I'll label them each with letters. Oh, maybe I can just label it. So rhombus then. A rhombus is this shape here. It has 4 equal sides, 2 pairs of equal angles. It's this one here. Important that you know these properties of quadrilaterals. Okay, the square. I'm just going to go square to speed things up. It has 4 equal sides and 4 right angles. So this one should be what you've got for the square. Trapezium. The only criterion for a trapezium is 1 pair of parallel sides. Isosceles trapezia, I guess. We looked at this. The other slopey side would be the same, and in which case then it has some equal angles as well, but not all trapeziums count like this. Okay, this one's a kite, and this is the description of a kite. This one here is an arrowhead, which is sometimes called an arrowhead kite. You can see the top of this kite has been inverted to make this convex shape. This is the information about an arrowhead. Then this one's parallelogram, and that's this one here. And so rectangle, rectangle. Very inconsistent with my capital letters and lowercase, apologies. Okay then, so diagonals are pretty obvious when we're talking about the rectangle, for example, goes diagonally across. Diagonals of quadrilaterals join opposite vertices. Now in the arrowhead, you might have noticed that it has this diagonals intersect at right angles outside the shape. So these vertices are opposite each other here. This would be the diagonal of the shape, but I can extend it. Remember, all lines are infinite. And so our diagonals intersect outside of the shape. Okay then, so we're asked to prove that in a parallelogram the diagonals bisect each other, and then we're also going to prove the converse of that, that if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So here's a diagram of a parallelogram. Opposite sides are equal. That's part of the definition of a parallelogram. Okay, so we can say that ODC, this angle here, is equal to OBA, which is this angle here. I need to provide a reason for that. I've got alternate angles between parallel lines. So it's a parallelogram, so I know that its opposite sides are equal in length and parallel. So using alternate angles that make the Z shape, I can say that those two angles are equal. I can also say that OCD and OAB are equal for the same reason. I can also say that DOC and AOB are equal. This is because they are vertically opposite. Finally, because I know opposite sides in a parallelogram are equal, I can say that DC is equal to AB. And so triangle DOC equals triangle, is congruent to triangle BOA because of angle, side, angle. Notice my notation here, when I've got 3 letters, I must write whether I'm talking about an angle or a triangle. So if these two triangles are congruent to each other, then I know that DO is equal to OB and that CO is equal to OA. Therefore, the diagonals bisect each other. Okay, part B. If the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. So I know the diagonals of a quadrilateral are bisecting each other. So that means OD equals OB, because that's what I'm told. Similarly with OC equal OA. Angle DOC equals angle BOA, because they're vertically opposite. Also, angle DOA equals angle BOC, because they are vertically opposite. So triangle DOC is congruent to BOA using side angle side, and triangle DOA is congruent to triangle BOC using side angle side. So if these triangles are congruent, then I know that ODC, the angle, is equal to OBA, the angle. And so as those two angles are equal and they are alternate angles, they must be within parallel lines, i.e. CD is parallel to AB. Similarly, I can show that with, for example, angle ADO and OBC, that they're equal. If alternate angles are equal, then they're between parallel lines, and so AD is equal to BC. I've got opposite sides being parallel, so therefore ABCD is a parallelogram. Okay, these are your questions to do for the remainder of this lesson. I will set up a discussion so you can ask me any questions. I will slowly, well, not very slowly, I will click through the other questions, and I've got the solutions on here as well, so you can pause at any point to either answer the questions or check your answers, check your proofs. Okay, thank you very much, and let me know if you have any questions.